Question number 13. This is another one brought from the topic, the syllabus of which is present only in JEE Main and not in JEE Advanced. Principle of Communication. Very straightforward one the question is. But let's say this is the equation of the AM wave. And on the basis of this, we need to calculate the minimum and maximum amplitudes of this AM wave. What I'll do is that, let me call this as omega 1 and this as omega 2. So if I slightly rewrite the equation, what is this going to be? This is going to be 5 plus 3 cos omega 1t multiplied by sine omega 2t. So this is what you get. Now you could say it's in a direct format where this comes out to be the amplitude of the AM wave. And what is the maximum and minimum value? The value would be 8 and 2. So the maximum and minimum amplitude as per our computation is 8 and 2. However, the options which were provided, that does not match. So 8 and 2, that's the answer as per the best of our knowledge. Let's go with the next one. Question number 14, that's from relative velocity. Look at the question. There are two trains in the picture, train A and B, moving in opposite direction with the velocity 36 and 72 km per hour. And inside train a person walks with a speed 1.8 km per hour in the opposite direction. We need to calculate the speed of person as observed from B. And the answer has to be reported in meter per second. So let's make a quick diagram that's going to help us. And to understand that, this is train A and here is train B. All right. So let's even write the value. This is speed of A, which is 10 meter per second, and speed of B, that is equal to 20 meter per second. Now as per the question, inside train a person walks in the opposite direction. So it's something like this. And how do we represent the velocity? We would say the velocity of person with respect to A. And that value is of course 0.5 meter per second. Right? So we got all the data. Now what we need to do is that we need to calculate first the velocity of person and then we will shift it in the frame of B. So this is something like this. First, velocity of person in ground's frame, that's VPA plus of VA, and VPA being minus 0.5, VA being plus 10. So that's going to be as 9.5 meter per second. All is done. So velocity of this person who is moving rightward, WRT ground, with respect to B, now would be 29.5 meter per second. Option number 2 is the correct one. Let's move to question number 15. Question number 15 that has been derived from kinetic theory of gas. And let's say there is a gaseous mixture consisting of 3 moles of oxygen and 5 moles of argon. Now this is diatomic and this is monoatomic. We need to calculate the total internal energy in units of RT of the mixture. So let's say now the total internal energy, of course, you know, is by the formula nRFT by 2, right? So let's start. First of all, let's consider oxygen. Oxygen has 3 moles, so that's going to be 3R, degree of freedom is 5T divided by 2, plus, then comes argon. Argon being monoatomic, the total number of moles is 5R3T divided by 2. So now that's simply going to be equals to 15RT, and in terms of RT, in fact in the units of RT, 15 would be the correct answer. So option number 2 is the correct answer for question number 15. Let's proceed further.